Hello guys, welcome back to our channel. In today's video, we are going to see about the isomerism concept. See, isomerism is nothing but where two or more organic compounds having the same molecular formula but different structural formula or having the different physical or chemical properties. So that is the definition of your isomerism. Yes, and those two or more components which are having the same molecular formula but different structural formula, those components, those organic compounds can be called as isomers of each other, and the entire phenomenon will be called as isomerism. So it is a simple definition of your isomerism. If it is asked in your examination, you have to write the same thing. Your isomerism is again classified into two types. That is nothing but structural isomerism and stereoisomerism. So in your entire POC 1, you have to give more concentration on your structural isomerism rather than your stereoisomerism. So that's why we are not going to discuss the stereoisomerism in detail in today's video. So we will be focusing more on our structural isomerism, where it is again classified into 6 types. That is nothing but chain isomerism, position isomerism, functional isomerism, ring chain, metamerism and tautomerism. Even for your examination point of view, it is one of the important concept which can be asked frequently. Yes. So here we are going to see the entire definition and your classification of structural isomerism in detail. Yes. First go one by one. What is exactly mean by? Now we'll see in detail about the structural isomerism. So structural isomerism is nothing but the two or more organic compounds having the same molecular formula but different arrangement of atoms within a molecule. Yes. So the two or more organic compounds having the same molecular formula but different arrangement of atoms can be seen within a molecule, and that can be called as structural isomerism. So structural isomerism is again classified into these all the types. So we'll see one by one what are the chain, position, functional, ring chain, those all the classification we are going to see in detail. Yes. So first one we'll see about the chain isomerism. So don't worry for making the notes in the videos, where the entire notes of today's class, of today's video can be uploaded in your description box. You can just open the link and you can download the entire PDF of today's video. Yes. So the chain isomerism is nothing but you have to write the first point as same. The organic compounds having the same molecular formula. This is same for all. It is same for all those types of structural isomerism. This is the first point which is same for all. The organic compounds having the same molecular formula but differ in, see, just take a look over here. It is a type of structural isomerism, that is nothing but chain isomerism. Yes, chain means you have to focus on parent chain. Yes. So the having the same molecular formula but differ in parent chain. Yes. Or you can just tell like they differ in the principal carbon chain. They differ in the parent chain, or principal carbon chain can be different for those number of carbon containing organic compounds. Yes. Just see a definition of your chain isomerism. These are the organic compounds having the same molecular formula. This is remain the same for all, but they differ in the parent chain, or your principal carbon chain can be different for those all different organic compounds, and those can be called as chain isomers of each other, and the entire process will be called as chain isomerism. When we see an example for this, like your butane. Yes. So this is nothing but your butane. Yes. If we will tell you an example of another compound and you can take a look over here. So this is nothing but your isobutane. This is your isobutane and this is your butane. See, one thing you can just focus here. Here your two carbon containing organic compounds. The two organic compounds having the same molecular formula. See how molecular formula we can calculate. C4H8. Yes. 6, 7, 8, 9, 10. Yes, C4H10, and here if you go on calculating the entire molecular formula of this isobutane, then you will be getting like C4H10. See, here molecular formula of these two organic compounds are same. Here also it is C4H10 and here also it is C4H10. But here your entire parent carbon chain and your principal carbon chain is different. Here it is butane and it is your isobutane, and it is your straight chain and it is your branched chain. Yes, so that is a difference in which these two compounds can be called as chain isomers of each other, where the parent chain, the principal carbon chain going to be different, where the molecular formula can remain the same. Yes, so if we see other examples like this, just I'll tell you. So this is your 1-butene. Yes, if I see another compound of this example, then we can take, yes, so this is nothing but your, this is your example of 1-butene and this is an example of 2-methyl. The name of the compound is 2-methyl propene. Yes, so it is 1-butene and it is 2-methyl propene. If we see the molecular formula of this, it is C4H8 and it is C4H8. They will be having the same molecular formula, but here the butane is there, here propene is there. Your length of the carbon chain may going to differ in the n number of your carbon containing organic compounds. Yes, so that is called as chain isomerism. If we go and see some other different types, first one is over chain isomerism and your second one is position isomerism. See, first point will remain the same. These are the organic compounds where two or more organic compounds will be having the same molecular formula but different, in which where your position of substituent, the position of double or triple bond, the position of functional group can be differ. Whatever going to differ, the position of, the name itself says that position. The position of functional groups, the position of double or triple bond, the position of substituent can be differ in the two or more organic compounds. So that can be called as position isomerism. If I tell you one example with an example, then it can be like here, we'll take butane. Yes, so this is 1-butene and if I take another isomers which can be like similar, just take a look here. Just take a look here. Here these two are called as position isomers of each other. But here the name of this compound is 1-butene and here it is your 2-butene. Here it is 1-butene and here it is 2-butene. Here what you have to concentrate more is the position of substituent, the position of functional group, the position of double or triple bonds is going to be vary. Yes, so like that if you take another example, another organic compounds, no need to worry about that, it will be remain same, but the position of your double bond, the position of your functional group or the position of substituent can going to be vary and that can be called as the position isomerism. Clear? See the third type of your structural isomerism, that is functional isomerism. So your first point is nothing but these are the components having the same molecular formula but different functional groups. Here what is going to differ? Here your differ will be in your functional group only. Means whatever two or more organic compounds are there, they will be having the same molecular formula. Yes. So they will be having the same molecular formula but their functional group is going to change. Yes. If we see the example like here. So it is nothing but here which functional group is there? Here this is nothing but the functional group ether. Okay, if we want to compare this with another component, then this can be your OH. Just calculate the molecular formula of these two compounds. It is nothing but C2H6O. Here C2H6O, C2H6O. So both the compounds having the same molecular formula, but here you have ether functional group and here you have your alcohol functional group. Yes, so that is nothing but the two or more organic compounds having the same molecular formula. Your molecular formula will remain the same, but they will be differ in terms of your functional groups, and that can be called as functional isomerism itself. If you want me to give one more example, so this is nothing but your ethoxyethane. The name of this compound is ethoxyethane, and the molecular formula, if we want to compare this with another isomer, then that is nothing but your, just take a look here. The molecular formula of this is C4H10O of this, and if we see this also C4H10O. Means these two organic compounds will be having the same molecular formula, but here they will be differ in terms of their functional groups. Here ether functional group is there and here your alcohol functional group is there. Yes, so this is called as functional isomers, and the isomers and the entire phenomenon will be called as functional isomerism. It is clear? If it is clear, we'll go with the next one. So that is nothing but your ring chain. Fourth one will be ring chain isomerism. So ring chain isomerism are nothing but, so first point, you know, they will be having the same molecular formula, but one component will be your open chain. Here one component will be open chain and one other component can be your ring format or ring chain. Okay, so one component, one organic compound can be your open chain and another organic compound can be your ring chain, but those two will be having the same molecular formula. Yes, these two organic compounds or different organic compounds or n number of organic compounds having the same molecular formula, but one organic compound can be open chain format and one organic compound can be in a ring format. Yes, so that can be called as ring chain isomers. If you see the example of this, so this is called as propene. Okay, so if we see another isomer of this can be a cyclopropane. Okay, if you see the molecular formula of this C3H8. Yes, so H6, C3H6. Here also CH2 will be there, CH2 will be there, and here also CH2 will be available. So you can see that these two organic compounds will be having the same molecular formula, but here it is in the open chain. It is called as a acyclic. Here it is a acyclic and here it is in the cyclic form. Okay, so that is only the difference between these two organic compounds, and they can be called as ring chain isomers of each other, and the entire phenomenon can be called as ring chain isomerism. Is it clear? We'll see the fifth type of your structural isomerism, that is nothing but metamerism. Okay, so it is something different from other types of your structural isomerism, in which how means same, they will be having the same molecular formula, where two or more organic compounds will be having the same molecular formula and functional group also will be same. Then in which factor they are differing means they differ in the nature of alkyl groups attached on the either side of the pentavalent atoms like your oxygen, nitrogen and sulfur. If you want me to give an example like this, just take a look. Okay, so this is one of your organic compound. If I want to compare this with another one, see, so these are the two organic compounds where they will be having the same molecular formula. Okay, if you want to calculate, you can calculate. They will be having the same molecular formula and also they will be having the same functional group also. See, just take a look here. It is also your ether functional group and it is also your ether functional group. In metamerism, both your molecular formula and functional group will remain the same. But whatever the arrangement, whatever the nature of alkyl groups are there on either side of the pentavalent atom, that is going to differ here. Yes, so here it is like the name of this compound is ethoxyethane. And here the name of this compound is methoxypropane. See, take a look here. Here the nature of alkyl groups attached on either side is going to be differ. Here it is ethoxyethane and here it is methoxypropane. So that is the difference with two or more organic compounds when it comes to your metamerism. They will be having the same molecular formula, they will be having the similar functional group, but they will be differ in the nature of alkyl groups which is attached on the either side of your organic compounds. Clear? So we'll see the last type of your structural isomerism, that is nothing but tautomerism. Yes, so tautomerism holds some different culture. Yes, so this is a type of dynamic, it is a type of your dynamic isomerism. It is a type of your dynamic isomerism in which, if I tell you an example, one form of organic compound can be interconverted into another form. So whatever your one organic compound is there, that form can be easily interconverted into another form. Okay, and they will be like here reversible. They will be so they will be like interconvertible in nature. So for example, most famous type is your keto form to enol form. Okay, so keto form can be easily interconvertible into enol form. How means, if I tell you an example, yes, so this is your keto form. Keto form means is nothing but they will be having the carbonyl. They will be having the carbonyl, and here just a minute, if I write the example here, okay, so this is your keto form and enol form is nothing but, okay, so can you just tell me the difference? What is the difference between these two? How one form of organic compound can be easily interconverted into another form, and this is called as keto form and this is nothing but your enol form. Okay, so keto form is nothing but because here carbonyl component is there and here you will be having the alcohol functional group. How it will be converted into means, it is done by, it is converted, it can be easily interconverted by the here shift of double bond. It can be done by your shift of double bond here and transfer of your hydrogen atom. Okay, so what are the 2 points you have to remember? Transfer of hydrogen atom, and second point is shift of your double bond. Okay, so whatever the double bond was there, it will be shifted here, and whatever the hydrogen atom was there, that will be shifted into this oxygen atom to form this another form, where the easily the keto form can be converted into enol form. Yes, just take a look here. One of the hydrogen atom has been shifted here, and whatever the double bond was there, it can be shifted here. And they are like here equilibrium is there. Like they are not completely reversible. They can be like easily reversible from one form to another form, and from this to this. And that's why it is called as dynamic isomerism, where one form of organic compound can be easily interconverted into another form of organic compound just by the transfer of hydrogen atom or by the shift of your double or triple bonds. So here our topic of isomerism can be completed. If you want me to do some other videos which are related to your concept, which are related to your doubts, you can just DM me so that we can make our videos on that. Thank you.